Hello and welcome everyone to today's cloud coaching session on cross-region replication using the OCI object storage service. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today we're excited to cover what a replication policy is and demonstrate how to define one. If you do not currently have an Oracle Cloud account, we've got a special promotion with extra credits so that you can try out OCI services and follow along with the demo today. To access the promo, please sign up using the same email you registered with for the event. We'll also be recording this session, and the link to the recording will be sent to you via email in the next couple of days. If you have any questions during the webinar, we've set up a channel in our developer public Slack called Cloud Coaching North America that you can access at the QR code or at bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there you can search for the webinar channel. We'll also be checking the Zoom chat and Zoom Q&A areas throughout the webinar, and we'll open up for live Q&A. Today's webcast will be presented by Stephen Nichols, Master Principal Cloud Architect, Becky Campelli, Staff Cloud Engineer, and Chinmay Thakar, Senior Cloud Engineer. So without further ado, I will turn it over to Stephen.
Great, thank you, Tara. Welcome everyone to today's cloud coaching session on object storage replication. This is the agenda that we're going to go over today. I'm going to spend a couple minutes and just go over object storage as an overview in case some of you are new to the service. I'll then spend a couple minutes discussing the replication policy feature within object storage. I'll go over the use case scenario or what I'll demo live later on in the session. We'll spend a couple minutes after the demo. Becky will introduce the Code Innovate program, and then lastly, we'll follow up with any Q&A you may have. So let's get started with the object storage overview. So what is object storage? In a nutshell, it's an internet scale high performance storage platform for storing pretty much any data. You can store unstructured data, you can store analytic data, log data, backup files, you can store rich content files such as images and videos. The key note here with object storage is it's a regional service, meaning it's not tied to a specific compute instance. Object storage is unique to each region. Within object storage, there's distinct storage classes. So if you have frequently accessed objects, there's a storage tier for that. And then for the less or rarely accessed objects, we have different storage tiers for that as well. From a data accessibility standpoint, you can access it in the context of OCI from anywhere inside and outside of OCI with the correct authorization or private access setup. The features within object storage are replication, which we'll cover in more detail, versioning, there's retention roles, you can do lifecycle management of the objects, there's multi-part uploads, there's also what's called a PAR request or pre-authenticated request that you can set up for objects. There's cross-bucket and region copy, and then the object storage service is Amazon S3 compatible if you'd like to access that via the APIs. And lastly, object storage is part of the always free tier. So if you want to try it out, it's available there as well. Some common use cases for object storage. It's commonly used in a data lake architecture. There's Hadoop support for that. For content repository, if you have an application that stores a lot of content, it's a good use case for that. Simply storing, backing up, and archiving data is a very good use case for object storage. And then if you have compliancy or requirement issues around long-term data storage, object storage would fit the bill as well. When it comes to access and object storage, there's many different ways. There's obviously the OCI console, the UI. There's also the OCI CLI or the command line interface. If you're a programmer and you like to use SDKs, Java, Python, .NET, Ruby, Go are all applicable SDKs that allows you to access object storage. If you prefer native REST is available. And then also, it's compatible. So there's API compatibility between OpenStack, Swift, Amazon S3, and as I mentioned earlier in the common use cases, Hadoop distributed file system has a connector as well for object storage. Now, when you're thinking of object storage, there's three main resources or components. There's the object itself. That object represents the data, the unstructured content, the image, the file, or whatever. There's the object itself, and then there's also the metadata associated with the object. It's good to note that each object is stored inside of a bucket. The second component of object storage is the bucket itself. Think of that as logical containers for grouping like content. You can create buckets within a region, and a bucket is also associated with a compartment as well. And lastly, there's the concept of namespace. So think of namespace as the outer bucket or the top level identifier within a tenancy. So when a customer, or when you create a new cloud tenancy, a unique system generated namespace is created for that tenancy, which overrides all or oversees all buckets within that tenancy. Now I'm going to take a moment to dive deeper into the replication policy itself, since we're going to demo that a little bit later. What is object storage replication? Well, I mean, it's simply kind of how it's defined. It's the process of replicating objects from one bucket to another, and that bucket can reside within the same region or a different region. You may ask yourself, why use object storage replication? Well, it's very good to support regional outages. So if you have a region that goes down, say Ashburn, for example, and your data is replicated within Phoenix, then you have all your data sitting in Phoenix, and it can help you with disaster recovery efforts. If you have requirements around storing data redundantly, meaning you need to store it in multiple regions for different requirements, object storage replication allows you to do that pretty easily. And lastly, if you have users spread all over the world and they're located in regional pockets, and you have to solve some possible data latency issues, you can store multiple copies of that data in regions that are closer to the users, which would help access latency issues. Now, when you get into creating a replication policy or defining a replication policy for a bucket, you have to think of it as a source and destination bucket. So when you define the replication policy, it does not automatically define the destination bucket. So the idea is you need to create a receiving bucket first before you define the replication policy. And when defining the buckets, those buckets can sit in two different tiers. So you can have a standard object storage tier bucket, or you can have an archive storage tier bucket for both source or target. When setting up a replication policy on a source bucket, that source bucket can only have one replication policy defined for it. You can't have that bucket replicate to two different destinations. Also, there's a maximum of one source for each replication destination bucket, which means that's kind of the inverse. You have a receiving destination bucket that's receiving the objects. That destination bucket cannot be fed by two source replication buckets, if that makes sense. Also, there's a maximum of one destination for each source bucket. That's another way of looking at it, is the source bucket cannot feed two different destination buckets. So a source bucket can only feed into one destination bucket. Furthermore, a destination bucket cannot be a source for another replication target, meaning you can't chain replication policies to go from source to destination, and then that destination is a source for another destination. So there's no chain replication supported. And you'll see this in the demo on the next bullet point. Once the replication policy is created and has designated that destination bucket is only updatable by the replication policy itself. It's locked down. You can't manually or through the CLI or the SDKs touch that destination bucket. Objects that are fed or led into the source bucket are automatically replicated to the destination bucket. The same as if an object is deleted. So once you delete an object from a source bucket, that object will also be deleted from the destination bucket. And also, if you update a source object or update it or upload it, it will also be updated and replicated to the destination bucket. And the last bullet point is kind of another way, I've hit on this earlier, is you cannot delete a replication bucket unless you stop the replication process itself, meaning essentially that bucket is untouchable unless you turn off the replication policy for that destination bucket, and then you can treat it as any other bucket going forward. I know that's a lot of information, but I'll demo it here in a minute, and hopefully it'll be more clear. So the use case itself is pretty simple. I'm just going to demonstrate. We have a existing source bucket that's in one region that already contains existing objects. There's an empty destination bucket already created in another region. Our source region is going to be Ashburn. Our destination region will be Phoenix. I'm going to create a replication policy on the existing bucket, which will designate the Phoenix region as the destination policy bucket. And then I'm going to demonstrate a simple uploading of new objects to the source bucket and show how they're replicated to the target or destination. And then lastly, one thing that replication policies do not address or touch are existing objects in a bucket. So if you have a new source bucket and a new target, that's great. It'll take care of all the objects. If you have an existing source object or source bucket with existing objects, we have to take care of those through a more manual process. So we're going to address the existing objects in the source bucket by writing or executing a simple Python script leveraging the SDK, which will essentially touch each existing object and trigger a replication. So at this point, I'm going to demo what I just talked about. So I'm going to bring up the OCI console. And here we'll see that I'm in a compartment called Cloud Coaching. I have a bucket called Source Bucket, and that bucket is defined within the US East Ashburn region. If you examine the contents of the bucket, and again, this is a very simple use case to demonstrate replication, but I have 5 existing files or objects in my bucket. If you look at the replication policies itself, you'll see that I have no replication policies defined at this point. The plan is to then, if you switch over to the Phoenix region, you'll see I'm still in the same Cloud Coaching compartment, but I'm now in a destination bucket and I'm in the Phoenix region. I have no objects in there, so it's an empty bucket ready to receive the objects. You can also see that there's no replication policies designating this bucket as a target or destination. So at this point, I'm going to switch back over to the Ashburn region, which is, think of that as my source. I'm going to go down and I'm going to define a replication policy. So it's as simple as you create the policy. You can give it whatever name you like. We're just going to default it to the date and time. I'm going to select the destination region as Phoenix. And then I only have one bucket in the Cloud Coaching compartment. I'm going to select that, and then I'll create the replication policy. Now, this takes a few seconds to create. Okay, now it's been defined. If you look down below, I have a replication policy created. It's nice enough to tell us what destination I'm pointing to. The Phoenix, my bucket name, it's active. and it shows the date that it was created. Again, I have 5 existing objects that are in my source bucket. You also see up here that there's a replication flag or identifier that's now green. It says it's enabled as a source. If I switch over to the Phoenix region, I look at my destination bucket. You now see that there's a nice banner or warning or informational message at the top that states that this bucket is a replication destination bucket. And it says that you're very limited in what you can do. Basically what I covered earlier in the PowerPoint. Essentially, you cannot delete, rename, or upload objects. If you like, you can read the documentation that it links you out to. It also shows that replication is enabled. If you click down on the replication policy option for this destination, you'll see that this bucket, you can see where it's coming from. You can see that it's coming from the Ashburn region and it's coming from the source bucket. So either way, whether it's your source bucket or destination bucket, you can see where it's coming from. So now if we jump back over to the Ashburn region, and we go to source bucket. Oh, let me switch back, sorry, to Phoenix. You can see that at this point, there's still no objects in this bucket. It's still empty, ready to receive objects from the source. So if you jump back over to the source region and bucket, you'll see that there's still the 5 existing files. I'm now going to upload 2 new ones. And these are just 2 simple files, text files, very small, but they'll just demonstrate feature of replication. I'm going to click upload. You can see that the upload objects are finished. If I click close, I now have my 5 existing files and I have 2 new files. Again, if I go over here to my replication policy, you can see that it's been created and ready to go. If I jump over to the Phoenix region and I go to the destination bucket, you now see that within the Phoenix region, within my destination replication bucket, my 2 new objects are there. So if I deleted a file from the source, it'll also get removed. But this is a simple example of showing how if I upload or touch objects in the source region and bucket, it'll get replicated to the destination region and bucket. So that's great for any new files. But we know that we have existing files that reside in this bucket, and we like to get those replicated as well. At this point, the only way to do that is to manually trigger a replication. If I try to copy these files using a console or SDK or CLI, it'll tell me I'm not able to update the replication destination bucket because it's locked down and owned by the replication policy. So what we're going to do is we're going to leverage the Python SDK and a very simple set of program. And I'll walk through this really quickly. A lot of it's just variables defining my environment. So at the top, if you're familiar with Python, I'm importing the OCI module for the Python SDK. I'm also getting all my OCIDs and authorization tokens and fingerprint and all that through a file. In this example, you can also leverage the OCI CLI config if you already have that set up in your environment. And then, again, this will look very familiar. The source bucket name is my source bucket. My source region is my US Ashburn 1. And then I'm just getting ready and establishing a connection to object storage for the source region and bucket. The same holds true for the destination. So my bucket name is Des Bucket. I'm in the Phoenix region. I'm setting up my configuration in order to establish a connection using the Python SDK object storage client connection. So once I've established my 2 connections to both the source and target, I also get the namespace. If you remember earlier, there's the object, the bucket, and then the namespace. So I need a namespace of the tenancy when I'm interacting with it. So I grab that using the a Python call. And then I have a function, and this function is really basic. It simply takes an object name and checks to see if it exists in a specific namespace bucket and region. And this is what I do to test to see if it exists. And so when we get down to line 30, this is really the meat of the program. I'm simply going to process or list all objects in my source bucket. And that's what this line does. For each object in the source bucket in region, I'm going to loop through that in a simple for loop, and I'm going to test to see if that file exists in the target region and bucket using the function up above. If the object does not exist, to me, that's an existing object. And I want that existing object to be replicated to the destination. And so the way that I have to do that today is using the copy object function within the Python SDK or any SDK. And so essentially what I'm doing is I'm literally copying the object over itself. The object hasn't changed. It's the same object, but I'm simply making as if I'm uploading it again, even though it's already there. And once I do that, the replication policy thinks it's changed, even though the file itself hasn't changed, and it'll trigger the replication. And then all existing files that were in the bucket and never touched are now touched and replicated over to the destination bucket. And if the object's already found, then I don't do anything about it, because that tells me that the object is already taken care of by the replication policy. Hopefully that makes sense. So at this point, I'm just going to run the script here in a terminal window. It'll take a moment to connect. And again, I'm displaying some simple messages here. You can see here that existing file 1.txt was not found in the target, so I triggered a replication. The status of 202 tells me that it was successful. The same message applies to the existing file 2, 3, 4, and 5. But then when you got down to new file 1 and 2, which I uploaded earlier in the demonstration, you'll see that they were already found and I didn't do anything with them. And so if I jump back over to object storage, again, I'm in the Ashburn region in the source bucket. You can see my existing files. If I jump to Phoenix now, and I go to the destination bucket, you'll see that my existing files are now there. And since they were taken care of by the replication policy through that trigger that I did in the Python SDK, they're now managed and owned by the replication policy. So if those files change in the source, they'll get reflected in the destination. So at this point, that's pretty much it for the demonstration. I know this was a simple example. I know my code doesn't handle things like pagination if I have thousands of objects or anything else, but I just wanted to show how to address files that are existing in a bucket that you want it to be replicated over to a destination region and bucket. So at this point, I'm going to stop sharing, and we're going to take a couple minutes, and I'm going to pass the baton to Becky Campelli, and she's going to go over a program that we offer here at Oracle to help jumpstart your cloud development in OCI. So thank you very much for your time, and take it away, Becky.
Thank you, Steve. All right, so I'm going to take a couple minutes to talk about the Oracle Code Innovate program. It's a program formed and fashioned for developers just like you. And I'm Becky Campelli. I'm a cloud engineer in analytics here at Oracle. I work on this Code Innovate team, and our focus is on innovating together with our customers to build out first pass prototypes on your most important Oracle use cases for a week at a time. So at its core, Code Innovate is like this master builder class that these two kids attend at Legoland. Whenever they go about once a year. They get to sit down for an hour, starting with a bag of disassembled Lego pieces, learn how to put together these pieces in a new way, led by the master builder, the gentleman you see in green up on the top right there. And over the course of that time, they'll learn new techniques to, assemble pieces in new ways, learning a new brick interlocking technique. Like you can see, they have formed these penguins with earmuffs that you see on the bottom right. And Code Innovate is very much like this. It's a master builder class, but for Oracle Cloud. And for 5 half days at a time, about 20 hours in a week, we get to work on your very own cloud use cases together. It's very hands-on and there's a lot of knowledge sharing. We dedicate our Oracle engineers online for these 20 hours with your team to build an Oracle Cloud and work on your very own use cases, whether it's in object storage, analytics, integration, data warehousing, many of the topics that you've seen on these cloud coaching webinars. At the end of an event, we provide the opportunity to showcase the solution you've created to any executive sponsors. So this could involving your very own team around you to work on any solution that you've seen either presented or just would like to explore in Oracle Cloud. So Code Innovate works by bringing your very own use cases. The value here is that we will work on use cases that are important to you versus just showing standard demos of our technology offerings. The value here is that we'll share knowledge and impart skills to you if you're new to a Oracle technology in the cloud. And this 4 hours a day is really a supercharged time where we get our hands dirty together and work out your toughest problems. And at the end of an event, you'll usually leave with a first pass prototype, a working demo of how you'd like an eventual solution to present. And you'll be coming away with a lot of those skills that you need to keep going in whatever technology you've chosen. So we have a special opportunity today. We have one that runs all the time. You can email Code Innovate, our team, to engage with us in an event at codeinnovate_us_group@oracle.com, or for this limited time here on this seminar, share your email address in the chat with us and we can contact you to start a conversation about what would you like to innovate together using in the cloud.
So with that, I will go ahead and conclude the session for today. Thank you so much. Have a great day, and we hope to see you again next time.